Hello everyone, good evening to all of you, and I welcome you to this 11th week of problem solving session of this course Advanced Geomatics Engineering. So hello everyone, I welcome you for this problem solving session. In today's class, we are going to discuss about some questions from previous year's assignment on GIS and some theory related stuff on it. And then after we will see some of the practical applications and case study of GIS using the same concepts. So let's get started. So when we talk about GIS, it is a geographic information system, which is made up of different components such as the hardware. It means the system in which you are working, whether it's a laptop or the systems or desktop or whatever. Then the softwares like QGIS, which we are already using. Some softwares are like commercial software such as ArcGIS or any other GraphGIS or some other so many software are there which are either commercial or either open source. So that comes under the softwares. Then the networks, so it's like combination of what or all the components are there. It's a network of it. Data anyway, when we want to analyze anything, we need data to start off. So it's kind of any data in which we are interested, whether it's related to the forest or rivers or urban areas or any related stuff. Then the procedures, so how we will proceed to do some task, like if something is there, how we will digitize our data. First of all, scanning of the map, then digitization of the features, then performing the analysis. So it's like how we will follow the procedures, and then people who will do all those work and then build up different portals or different applications so that other peoples also can useful, and it can be useful for decision making purposes as well. So now, with this brief introduction about GIS, we will start our question and answer session. So the first question is, the GIS uses the database code blank to store the data and linking the
Hello, sir.
Yes.
Sir, use screen not sharing.
Okay, just a minute. Is it visible now?
Yes, sir. Visible.
Okay. So what we discussed the different components of GIS, such as hardware, software, network, which is a combination of all data, procedure, and people. So next one is the GIS uses which kind of database to store the data and then to link the data with each other. Or it's like any kind of database, if you take, how will you relate the informations with each other?
Spatial data.
Yeah, so what is that name of database when we use like in database also? Let's say example let's say you have the different houses and houses has number. Let's say the plot number or something else or some unique identification feature. And now some of them are identified for the sudden inspection for this, let's say Swachh Bharat Abhiyan. So for that we have we have list of houses, their plot number. So if I want to combine, like if I want to find out where those houses are located, so I will take the main directory and I will find the name of the plot number and compare it in both the database. So it's like two tables are there. In both table, one unique feature is there or unique attribute is there, which will link both the data sets. So this kind of database management system is known as which kind of system? So it's known as a relationship database
So
management
relational
system.
DBMS.
Yeah, DBMS, in which like one attribute is there which will link the two different tables.
ID number.
Yeah, so ID number, or it might be a plot number, or if you take the data of students, so it might be a roll number also. So it depends, like any kind of unique feature it will take, which is available in both the files. So the correct answer for this is either RDBMS or a relation database management system. Now, when we talk about the different softwares, which of the software which we use for, let's say, this GIS operations is open source from the given options.
ILWIS.
So yeah, exactly. It is a private or commercial software
Commercial.
or not.
One is not and the open source
Not,
software.
it's not. So in like classroom, you have this table for two slides, which is showing the all the commercial as well as the open source GIS software. So there you can check it out like this global mapper, which is like given by Blue Marble, which is a commercial one. Whereas GrassGIS and QGIS, like Quantum GIS means QGIS, both are open source. And then this ILWIS, which is Integrated Land and Water
It what
Information
other
System.
dimension.
It's also open source software, not a commercial one. So you just go through this tables or slides which is given for commercial as well as open source GIS softwares. In commercial one, mostly like most famous is the ArcGIS, then Bentley Maps are there, Map Viewer is there, Global Mapper is there. So this like couple of commercial softwares are there. Now we'll go to the next one, which is like vector data topology refers to numeric data, which clearly describes blank and blank between the map feature. So first of all, like vector data, it might be three kind of data, which
Point
is a
line polygon.
yeah, point, line, and polygon. Now, if two points data are near to each other, or two line data is near to each other, or two polygon data is near to each other, topology refers this how these data are connected with each other. Just a minute. So here the word topology refers like how these data are related to each other. So when we do this kind of operations in the QGIS or any GIS softwares, so what are the features or property of this vector data is related, which is connecting two different polygons or features. So you might have learned about this word, three words, which is the adjacency, containment, and connectivity. So
Sure.
this correct answer for this one is this three parameter, like this three property: adjacency, containment, and connectivity. So if we like just decode it each and every word, then adjacency is means like how two data are like near to each other. Let's say one road is there, near to there some park is there, so they both data are like near to each other, so they are connected with each other with some line or something, or they are just next to each other. So adjacency is like how it will just show the nearness of the data sets. Then the second one is the containment. So let's say if you have a data of entire city, and in city you have the data of hospitals which are located within the city. So it is like how which data is contained by which feature, polygon feature or other features. So that is like containment, whether the data is present inside the given feature or the outside, or basically what is the probability of finding that inside that. So coincidence basically, or containment. And the third one is the connectivity. So how each of it like connected with each other. In that we can consider examples like road network or canal network or the river network, which will show like if something will happen, how it will like move with each other or how it will like connect with each other. So be different nodes. So when we refer to the topology, it refers basically describes the three different things, which is adjacency, containment, and connectivity. So the correct answer for this is these three words. And now the next question is like which of the following indicates a topology error? So now if we connect the two feature by this line point or polygon or so, any combination of it, then which kind of error might occur? It is because of this topology. So
Digitization error.
yes,
Uh, Polygon features.
so think about the digitization error. So digitization, which of the following indicates topology error? Topology means connectedness. So digitization is means like you have raster data, you are converting into vector data sets just directly, like either scanning or some other way around. So that is a not correct option because it will not have anything related to the topology. We're just digitizing the things. If map is there, we are just scanning.
Unclosed polygons.
Yeah, so the unclosed polygons, gap between the polygons, like if we are making a polygon, let's say uh, once we digitized all the, like basically we scanned all the old maps, then we are making a boundary around the, let's say lake area. So what will happen? We are making a polygon like this, and at the end we are not connecting these two dots. So it will create a error of topology because it is a closed, not closed or open polygon.
Unclosed polygon.
So this kind of error can happen. Then gaps between the polygons. So let's say one polygon is there, and then you have something like this, which is somewhere intersecting and somewhere having in difference between it. Like this kind of error will happen in the data which are like, you can take a network of, let's say, a map of state map, country map, or you can say map of district. So in that two districts are near to each other. But if you find some kind of space in between, it will like have the error. It is just because of the error, which is like topology error. And this is like related to the polygonal features. So these three are the correct answer, whereas the digitization is not because of this topology. So here you can see like how will it look like. So this is a polygon. So you have some space in between. So this is also known as a silver polygon, which is like because of the overlapping issues, and they are not able to connect near to the other areas. And then when you have river or road network or data such like this, but if you have not connected this data when the 2 points are meeting with each other, then also it will create the topology errors. So the next question is, the silver polygons occur due to which of the phenomena?
Overlaying polygons.
Yes, so there
But
is issue with overlaying. So because of that, it will happen. So silver due to double digitizing, like we are digitizing 2 times, so that it might be overlapping with two different polygons, and because of that, this issue is. And the next one is the process of converting the raster data into vector data is known as a
Digitization.
digitization. Then so basically this is a process known as a digitization, and like what kind of errors you can expect by doing the digitization. So you can expect either overshoot, undershoot, or spike. So it like, if you are digitizing something, sometimes you might be cross the boundary. Like if some lake is there, let's say some lake is there like this, and when you make the polygons, what will happen? You will make something like this. At some point, it is just going outside the lake, because consider this lake is having very big size, and then when you start digitizing you will feel bored and you will just not do all these things digitization in one go. So because of that, or because of some other reasons, it might be overshoot or undershoot the like digitization, and sometimes this kind of spikes can also happen if you have some other gaps. Then the next one is the, which is the type of database, or which are, so which of,
it's a networking and a relational database.
yes, network database is a database. Hierarchical also, because it's from name only itself, like it represents database. Relation database also. Now whether this will be a database or not. So will it be the database or not?
Not.
So it's wrong, like all of them are the type of database. So flat files are like this. So you just have tables which are like very flat. But if you have some unique identification inside the flat files, you can connect and make a database out of it, combining the unique features, which over here it's a pin number. So zoning, how we are doing zoning, residential, commercial. So like this is how network will look like, hierarchy will look like, and then the relationship with each other. So all of them are the type of database. Then the next one is you have to find out the correct statement from the given statement. The first one is the vector features have attributes which describes the property of the feature, which is true or false.
It's true.
So
True.
it's true because we have some unique identification, as well as the, like if you have road data, then the length of the roadway or like width of the roadway or whether it's a state highway, national highway, or length or width or lanes, how many lanes are there. So those kind of attributes will be there. So it will give the idea about the property of the feature. Then the next one is there is one record per feature in the vector layer. So it's not necessarily true, like not every time. There might be more than one record also. Or will it be one? Because see, here if we like just see the, so I will show you GIS file. So if we have, let's say, we'll just open some data. So let's say we have this data of, let's say, libraries. So what this question is telling, that there is a one record per feature in the vector layer. So if we take one feature, which is this polygon features, so if we like see the attribute table, so if you want to see the attribute table, right click and click on the open attribute table. So it will show the name and the description of library. So for every one feature, you will have the corresponding description. So if two are there, then you might be having issue while connecting it with the database, because like one thing cannot have multiple records in GIS operation. Otherwise, it will create the problem in storing and connecting the data sets. So because of that, like there is only one record. Like you can add the different attributes and make a different list of the attributes, but record will be one only. Then columns in the tables are the records, so not columns are the attributes. So as we have seen here, that the name of the library and the description. Apart from that, we can add the different attributes such as the size of the library, how many people can it can accommodate, or how many books it's there, or different books according to different genres, or similar attributes we can add over here. And then the next one is the attributes are sorted in the tables. So attributes are stored in the tables in the form of table format, so which we also already saw. Then the next one is the raster data is preferred in GIS for what kind of operations? So for which data analysis we need raster data? So the first one is the shortest distance analysis, where like from name suggests, like if any network is given or
Networking analysis.
yeah, so in network analysis, what kind of data we need? Its name suggests we need network data. Network is which kind of data? Raster or vector? It is mostly kind of vector data. Let's say network of road or network of, let's say, canal or river. So all those are vector data. So it is not preferable we use for network analysis. Similarly, we do not use the like raster data or buffer analysis. Buffer analysis is means like if you have road, you want to create a buffer around it for 300 meter for the widening of roadway. So for that we need a vector file, not the raster file. So for those kind of application also, this raster data is not useful. We need vector data. And similarly, shortest distance also, like if you want to find shortest network or distance, you need a network of a distance file, or you need a basically a network. So that's why this also requires the vector data. So the correct option here is a routing flow. Now, what do you mean by routing flow is that we will discuss through the application in today's class. So we will discuss in detail like how to route the flow and create a river network using the given any DEM and raster data. So that we are going to do entirely in the hands-on. Then the next one is the what are the derivative of DEMs. So if we have DEM data, which is like digital elevation models, then what kind of things we can do here? So if you are not aware about DEM, I think this is
Uh, one
yes.
Determine the volume of the reservoir,
Yeah.
calculating the amount of the mineral removed during this mining and digging,
Yes.
or
So determining the parameter for
parameter of
volume.
hydrological model.
Yes, that also we can do. But soil type we cannot do it because like just using the elevation data we cannot predict what is the type of soil. So that is a wrong answer here. So with this we will like just end up this question answer session. Now we will start with the like part in which with the hands-on session. Any doubt till now?
No, sir.
Okay. So now let's get started with the. So first of all, we will start with the raster data only. So like till now in hands-on session, we worked with the like more or less with vector data sets. We also did the digitization as well using georeferencing. We created the digitize the feature as well. So we all know those kind of things. First of all, we will see like this topology error or those errors which we discussed today. So how will that look like errors? So in that, like if you have this data with you, you can open this common data folder in which administrator boundaries are there. So let's say if I will open the district boundaries, so you have this kind of map, okay? But now let's say if you zoom to this region, let's say where too many polygons are there. So what will happen is, see, polygon should be like this. But in case if it is crossing with each other or if it is not closed properly, you might have problem in doing any kind of analysis. So your polygon should look like this. See, there is a gap in between. Now let's say when two bodies are joining with each other, so it should not have any gap in between. If it is having any gap, it means that part is having issue. So here it should like this. So here you can see some features. See here, like inside the polygon, one more polygon is there. So that is will create some kind of issues while doing the things. Now also you can see this kind of things. Or where like most of the boundaries are coming, you will see those kind of errors, topology or those kind of errors. So let's say if I want to do any operations on this, it will show me the errors such as let's say if I will start doing any operations over here, let's say I will do union. Let's say we just merged all the file and make a entire big file. So let's just use this option dissolve. So when you do any kind of operation and if you are having topology error, it will suggest you this kind of error that feature 1 from the district boundary has invalid geometry. Please fix the geometry or change the processing settings to ignore invalid input features. So from this entire polygon, some polygons are there which are not generated properly and they are having some errors. So that's why what it is telling you is it is having invalid geometry because basically it is a topology error and you have to like first of all fix your shape file. So how you will do is for that in GIS one function is like tool is there which is fix geometry. So if you use this tool, what it will do is this algorithm attempts to create a valid representation of a given invalid geometry without losing any of the input vertices. So already valid geometries are returned without any kind of interventions and always output will be multiple geometric features like whatever you have. So that is like if you have any data like from this image, it's very difficult to identify where this error is. But yeah, if you can do any kind of things or analysis, it will give you this kind of errors. That means if you have an invalid geometry, first of all, correct that, and then you can use this file for the other analysis. We can see over here also some features are there. So it will be like most probably where this are crossing each other different states, or some kind of area is there which are in like uh, conflict, or some kind of between the two different states, you might get those kind of errors. So you can just find out where it is having error by zooming in or zooming out. It is has. So that's it related to that. Now we will start with the next thing, which is interpolation. So the thing is, now if you have vector, you have worked with the vector data, but now when we talk about the raster data, which is in terms of image, or this is continuous pixel data. So first thing comes into mind, how to generate the raster data. So one way to do that is using the satellite. Satellite will capture the different images that you can use as a raster data set. If you do not have satellite images, then what to do? So in that case, what we do is we do the surveying operations. So we go on site, we collect the data using the instruments such as the chain survey, or we do perform the chain survey or total station survey or the GPS survey, or any other kind of surveying methods. And then you will collect the point at different locations, and then you will note down the either the, let's say you can collect any data, whether it's a temperature data sets, or it will be the elevation data type, or soil porosity data, or the soil moisture data set. So any kind of data you can collect, and then you can make a raster out of it. So first of all, we will see the process, like if you have field based data sets, so how to convert the data into raster format. And once we have raster data, then how to process those raster data using the various tools which are available in GQGIS. So now for doing that, we will just open this folder, D12 folder, which is interpolation. And over here, one DEM is given to us. So we will open that DEM. And in this DEM, so this is like having some, you can see this black line is represent low elevation areas, which might reflect the rivers or something. High elevation is representing the mountain peaks or the ridge lines. So now what we will do is we will try to generate some random points in this particular file. So basically we'll go to vector, research tools, and random point in extent. So now we will just put the random extent. Let's say we want to this interpolate this area. So in this area, let's say I want to generate the 500 points. And then if you want any minimum distance between 2 points, you can also specify that. And then after we'll just run it. So what it will do is it will generate the 500 point in the region where I like whatever I have selected. So I have selected this region. In that it has generated the around 500 points. Now we want to extract the raster value, which is the digital elevation model. So for that, first of all, we will see the attribute like table of this points which we generated. So it has just ID associated with it. So if I want to add the latitude and longitude along with as attribute, so what I can do is I can go to this open field calculator. I can write here let or long, whatever I want to add. Just click on decimal number because the let values will be very less, so it need to be stored in the after decimal digits as well. Then over here you can just write the $y, so it will add the latitude. And then similarly we will add the longitude. So here we will put the x. So we have added the lat long, and now corresponding to that we want to add the elevation value, because whenever we do survey on site, what we will do, we will mark down the point location which will be a lat long, and then corresponding value we will measure whether.
Hello, sir.
Yes.
why you use in this field dollar symbol?
So here there are different tools are there. So here, see, I want to automatically extract the X location of the points.
Yes.
So for that, there are here you can see there are different tools are there. Here, if you go under the geometry tools, there are
Yes.
the different tools related to geometry. So this tool is area, which will calculate the area of the feature, because here we have point feature, so we cannot calculate the area. So if you just go down it, you will have so many tools related to the geometry. And if you go down, there is a tool name is under $X,
Yes.
which will return the X coordinate of the current point feature. And if the
Okay.
feature is multi-point feature, then the X coordinate will be the first point to be returned. And there are two one with dollar and one with the without dollar. So in without dollar, if you are using, you have to specify the geometry of the object. And
Okay.
if you are like, you have to write it in like this X and then geometry like this. And this is like not valid, because this is useful when you have some kind of let's say multi-point data, like say which is in polygon form or some other points. So basically I mean, you have to specify it like this. So X geometry from, so whatever the point, let's say if you have point 2 3, or if you have a number you do not know, like as a vector data already in GIS, then you can use like this.
Okay, sir.
Basically you have text file, in
Okay.
that text is given to you. And on the other hand, if you just use $X, it will just directly put down the values. And you can see the preview also as well over here. So like this, you can add latitude or longitude. And now the third column we have to fill with the given data. So that data might be anything. It might be elevation, it might be a temperature, it might be a slope, or it might be can be anything. So actually we have to do survey on site, and we will collect all this data. But right now what we will do, we will generate the value. We already have the how this DM will look like. So we already have the raster data of that. So what we will do, we will just extract the value from that given DEM. So for that we have tool sample raster value. We just want to extract the raster value of the given DEM. So we will use this tool raster sample raster values. First of all, we have to give as input the points which we have with us, and for those points we want to extract the elevation value. And then you have to specify the name of the field, like field you are using the elevation data. So I will write elevation there and just run it. So the new file will be created, which will have all the attributes inside that. So it has added one more column, which is the elevation of that point. So we got latitude, longitude, and the elevation. Is this clear till up to this point?
Yes, sir.
So what we want to do is we want to just
Sir, in
convert.
this elevation point represent
Yes.
that overlapping this raster image
Mhm.
in this particular point.
Yes.
Okay, sir.
So generally now what we are doing is we are trying to create same raster file for this area, but this is the data which we have collected through survey, and now using this data we will create something like this. So
Okay.
whether we are able to recreate the same geography, or basically that is our task. Okay,
Okay.
so this
Okay.
will be helpful to you in like if you went to do some kind of mapping on site. So how many data points are required? From which part of the terrain you should collect the data, so that it can represent the proper geometry of the given geological feature or the terrain. So that is useful for that purposes. So once we will create this, we will compare the accuracy of with the original data. So now we have to do the interpolation. So for that, one method is there, which is IDW interpolation method. So it's an inverse distance weight. If you just Google it out, so like how these methods work. So basically, so how this method will work is like, let's say if you have one terrain, So let's say you have this terrain. Okay, you want to find out the what will be the value of data at this yellow dot, and the data which is given to you is as like all the black and red data are given to you. So first of all, you will see the nearby region, and we will see how many nearby pixels are there, or points where the actual data is given to you. Now you will take a, just a minute. So in the interpolation, what we will do is, first of all, so now this point is given to us, we will see the nearby point, and then after we will do this interpolation. So let's say I will explain you in the PPT. So basically, we are given the different points where the elevation is known to us. Let's say these are the given point. And we know that the elevation at this point is, let's say 15, or elevation at this point is, let's say 12, elevation at this point is 18, elevation at this point is 17, and elevation at this given point is 10. Now what is the task given to us is find out the elevation at this circle. So what we will do is, first of all, we will find out the distance between all the features, which is we will denote with the D1. So this shapefile of this circle we already have, so we have the coordinates for all the points, and we can find out the distance between those two, like each and every point. So we'll find out the distance D3, and between this and this point D4. So basically this point you will consider, then this point which is D5. Now generally if you want to find out the elevation at say this point, which is, let's say we denote it as A, the one basic way what you can do is elevation at A is the average of all the nearby point. So simple elevation can be written as H is equal to, let's say 15 plus 12
plus 10 plus 17
12
plus
plus 10
8.
plus 17 plus 18 divided by 5. But now in this what will happen, that we will giving the equal weightage to all the points. So if some point is having too far, and if it is having higher elevation, then the dominance of that thing will come into picture. So what we want to give, we want to give the weightage according to the distance. So if the point is nearby, give more weightage. If point is far away, give less weightage. So what we will do is, we will divide all the like values with their distance. So 15 by D1, similarly 12 by D2, 10 by D3, 17 by D4, and then 18 by D5, and then divided by all the feature, let's say 1 by D1. So here we are taking inverse weight, like 1 upon distance. That's why name of this method is inverse distance weight, 1 upon D2. So like this we will create the entire thing, and then we will find out the elevation of the point A. Now we can also use the different D. So instead of single degree, we can use the 2 digits also, say like this. So this is which kind of polynomial IDWD you want to use. So that will be like our N. So like that you can do the IDW interpolation. So that we are going to perform. So first of all, we'll select the random points which we already have. Now which particular field you want to interpolate. So I want to interpolate the this elevation field which I generated. So I will select that elevation field, and then you just click on this plus button. So it will add this elevation into the given attribute table. Now this is the distance coefficient. So whatever the weightage we have discussed, it's a linear coefficient like 1, 2, 3, or 5, like that. And then there is a extent. So for how much area you want to create the DEM. So basically, I want to create the DEM for the, let's say, this part, whatever that's given to me. And then what will be the size of your pixels? So what we will do is we will create the same file, same pixel size, which our original DEM has. So our original DEM has the pixel size of 0.000277. So we will create the DEM with the same pixel value. So if you see, if we give the same pixel like 0.000278, it will generate the 187 rows and 2110 columns. So as you know that all the image are in terms of matrix only, so it has 187 rows and 2110 columns. And then after doing this, we just click on run and it will generate a raster layer. So now our raster layer is generated, and you can see now that how these two rasters are looking like. So this is our original raster and this is the raster which we have generated. So now can you see any difference? Both are same or they are having some issues? So I will just remove these points. So first of all, like, are the original raster and the raster which we generated through interpolation, both are same or not? This is the original one and this is the new one.
Both are not same.
Not same. And why? Because wherever you can see, wherever we have points, it has given more weightage, because it, like, if I want to find out the elevation at this point, what it will do is it will take the help from the nearest neighbor or this nearest point, and it will assign the elevation according to that, or it will give more weightage according to that. And because of that, in that particular area or where near to that pixel, you will see the values are concentrated over that only. So if I see here, the value is 3436.75. If I see the nearby pixel also, it is similar to that only, 466. So wherever the data is there, it will generate the similar values. And because of that, this IDW method will not work in terrains which has so many ups and downs. So you can see here this like data is changing from like 2196 to 7108. So the elevation difference between the different features is too much, and that's why this method is probably not working for our region. So now what we will do is we will see the accuracy of this method, like whether how much accurate it is still. Whatever it is, we'll just see how to see the accuracy. So for that, you can install one plugin, which is Profile Tool. So from the plugin option or plugin menu bar, click on that, manage and install plugin, and just search for profile plugin. So which will look like this with some green color of cross section is given, and name of the plugin is profile tool. So it plots the terrain profile. So once you install it, it will look like this. Now what we will do is we will just draw a line in the raster data, and then we will sorry. So first of all, we will add the layers here. So first of all, we will add the interpolated layer, and just select the layer and click on add layer, and click the sample DEM and click on add layer. Now we'll change the color of both the DEM. The original one we will use it with black color, and the one which we generated, I am keeping it as a red. Now I will create a line in this part. So now you can see in this graph that this black line is the original line, and then this red one is the line generated by the IDW. So along with this line also, you can see one red colored dot is also moving. So one thing which you should notice is wherever it is coinciding with the points. See here, whenever it is passing through the point, the error is minimum, because in that region it is able to interpolate properly. So here, see, so many points are there nearby, so it is able to capture the variability very well. But as we move away from the points, so in this region basically the very less points are there which are near to the given interpolated feature, and because of that you see the disparity between the original DEM and the interpolated DEM. So because of that we get the error there. And similarly, if you see do this observations, you can find out where the error is high. So if I want to represent this valley of this river, is not able to like see this much difference is there. The actual depth of the valley is at 3385 meter, and then the corresponding one is a 3570. So this much difference we have. So if we are doing any applications related to the water, it will not give a proper picture of it. So we have to like if we go on site, so this black color line is the original site data. So we have to collect the point in such a way that it will represents the original topography. So if I go on site and collect the data points, so I will collect the data from here as well, here as well, here as well, here as well, in such a way that it will give me the proper river bound like river profile, not the tentative profile or the tentative profile of the area. So like this, you can use the different interpolation method. You can compare which interpolation method, which for which coefficient is good. So what we will do is now we will do the same interpolation method, but with the different coefficients. So we'll just put the elevation value. Instead of 2, we'll just use the coefficient 5, let's say. And I will use the same extent which I used for my previous layer. And then 0.000278. And then just run it. So this is the new layer which it has generated. I will just name it as order 5 with 5. With coefficient 2. So now we will just remove all the layer one more time. Sample DEM is there, and now we will add both the layers. Interpolated 2 and interpolated 5. One will keep with the red color and one will keep with some other color. Let's say we'll go with the blue. So you can see now the earlier one, earlier one, I've given the wrong names here. The earlier one was 2. This one is 2. This one is 5. So you can see over here, so like this blue line. So here you can see now this, the the earlier one, which we generated, which is not giving like able to capture the variability of this valley. But this fifth degree coefficient is able to capture the valley properly. So you can see this effect of this various coefficient also. Now we'll see the some other stretch. Now also you can see like how these two methods are behaving, like with the different coefficients. So you have to find some coefficient value which represents the proper representation of topography. And if we see also like this, just put down these points. So this fifth one has see, it's very good representation of topography compared to the earlier one, like this. But still that is not exactly correct. Now we will use one more method which is known as a TIN, which is known as a triangulated irregular network interpolation. So in that also we will do the same process. We'll click on sampled elevation, we'll edit, And here also you have a different interpolation method. So whether you want to do linear interpolation or the cubic interpolation. So let's say we'll go with the cubic interpolation and extent we'll select with this whatever the interpolated layer we used earlier. And the raster size also we use the similar one only so that we can compare all the layers with each other and just run it. So this is the interpolated and layer which I got from this tin interpolation, and I will just name it as a tin. And now I will also add that layer that I will express using this, let's say, dark blue color. So now you can see, if you see the tin, it's like very accurate representation compared to the previous one as well. So now we'll just see some part where points are very less. So now we will create a line where these points are very less. Let's say we see in this region. So here also you can see this blue one and the tin and interpolated phi are trying to capture the topography very well. See, these two are doing very well compared to this interpolated with the coefficient 2. So like this you can do as a research, like you can just find out which coefficient is good to create a better representation of the given terrain, and then which interpolation method with which kind of interpolation. Let's say if we are taking tin also, whether linear interpolation or the cubic or binomial, or which kind of interpolation will look good, like able to create a good terrain. And then apart from it, you have so many interpolation related IDW and TIN is there. Apart from that, there are different interpolation tools are also there in this. If you see these things, so this BES spline tool is there, which is bilinear spile interpolation. Then this is RST is there, which is one more method of doing the interpolation. So there are a couple of interpolation methods which is given. You can use any one, and then you can find out the kriging is there, cubic spline is there. So you can find out which interpolation method is good for your area. Any doubt till this point?
No, sir.
Okay, so can anyone give me the example, like where can I use this kind of interpolations in real life applications?
Forest canopy measurement.
Yes, so we will measure the canopies, but what do you think? Like if you see, if you want to measure the canopy, whether we do the survey or whether we go with some kind of, let's say, lidar or some drone kind of thing.
Actually,
Depends.
working this surveying methods.
Yes. So here, like, depends on the cost of the project or what kind of objective it has. If it is like not that much, we will go with the some instruments are there which will measure the canopy of the plant. So we measure at different locations and we'll see at which location canopy is high, and we'll make a map out of it. The second example might be a groundwater data, which is like wells are there. You will measure the water level in the well at different location. So well will represent as a point data only, and attribute you will add as a water depth. So now you will collect the water depth before monsoon, and you will collect the water depth after monsoon, and then you will find out the area at which this groundwater recharge happened, and the area where the ground depletion happened. So you can make a raster out of it, and you can find out probable area from where you will get the groundwater dug at this much depth. So that kind of applications we can also do. Further, we can do the analysis related to the temperature, the soil porosity or soil strength parameter, because we cannot do the soil testing at each and every location. We have to do at some critical site, and then we will generalize that thing using this interpolation or any other methods like this. So, okay, so now what we will do is we will see some of the uh, tools which you can use with the DEM data. So let's say this is the DM which is given to you. Okay. Now we will see what kind of operations we can perform on this raster data sets. So first of all, when we have this raster data, we have raster terrain analysis. So this DEM is representing the elevation data, which means it's a terrain information, and this kind of tools we can use for the terrain analysis. The first one is the, like, we'll just go with this hillshade. So what so hillshade is there, relief is there, slope is there. But one thing, like before doing any operations, what you can do is you can convert your data from degree to meter. So if you see, if you right click to your data and check the properties, or if you download any data, the data will be in the degree format only, like the unit of the data will be in degrees. And you can see the coordinate system also. So all the units are in degree. Now what will happen, that if you take the raster data, this data is in degrees. So if you zoom it, it will represent like pixels, different pixels. So width and length of the pixel is in degree. But if you take the third dimension, which is your elevation, so that is in meter. So it will create the problem with the units. Why? Because let's say if I will tell you that you have to calculate the slope. So how will you calculate slope is change in y divided by change in x. So change in y you will get from this DEM layer, which is in meter. But change in x you will get in terms of degree, because your data is in degree. So that it will create the discrepancy while doing the analysis, because one unit is in meter, one unit is in degree, and that's why we should not do that thing. And first of all, whenever we have this kind of data, we will convert it into a reprojected system which is in meter. So first thing, what whenever we have DM data, we will do the change the projections. So for that, a tool is there which is WAP reproject. So you have to select your DM, and then under target CRS, source is same only. Source is mean the coordinate system of your data, which is 4326 only. If you will not provide, it will automatically detect whatever it is showing over here. Target is in which coordinate system you want to convert your data. So right now I will go with this. So if you just click on this, like earth here, it will show you the different coordinate systems. If you see over here, it has geographic coordinate system in which units will be in degree. The another one is projected coordinate system in which the units will be in meter. And then if you want to create your own coordinate system in other units, you can use that as well. So I will go to this projected coordinate system and I will select the coordinate system which is applicable for India or the given region. So here you can see whatever the coordinates you take, it is applicable for which area. It will show you it in preview. So I will select a coordinate system which is WGS84 World Mercator, which you can also find using this 3395. So this coordinate system is in beta and it is applicable for entire world. So if you have any study area anywhere in the world, you can use that. So I will use that, click on OK, and I will run my analysis. So I reprojected my data. If you now right click to the properties, and if you check, your units are converted into meters. Once your units are converted into meter, you can see now the size of the pixel. So it is around 30 meter pixel. So this is the first step before doing any analysis with the raster data. Once we are done with this, now we will do the terrain analysis. So first of all, we will create the hillshade. So for that, you have to select the elevation layer, Z factor, azimuth, vertical. So basically what is hillshade is, if let's say sun is there, so if some elevation or some topography is there, how it will generate the shadows at different time. So this azimuth and vertical angle is parameter for showing the position of sun. So if I will just show you a bit. So basically we can use our terrain like this. And then so what it will do is so it will generate a layer something like this, so that you can see the different shadows like this. So now you can like visualize properly where river is there, where the ridge line is there, and so on and so forth. So here it is given the two different parameter, azimuth and the vertical angle. So now how will it generate the shadow is means that azimuth it means how it is like in which vertical angle is means angle with this like horizontal like vertical line with what much angle it is making. Azimuth angle it means is the 0 to 360 degrees. So basically it will represent northeast, south or west, and then it will like the elevation will respond like how at which angle the sun is there. So if I want to specify the location of sun, I will have to give two parameter. One is the longitude, so you can see here in this figure as well that at different time what is the location of the sun, which is described by this vertical angle, as well as this horizontal angle, which is known as azimuth. So this two parameter it is asking in this tool. So azimuth is a horizontal angle and this you have a vertical angle. And Z factor is if your data has very less change in the elevation value, so it will automatically exaggerate the value of elevation by the given factor. And just I will run the analysis. So now you can see your data is converted like this. Now you can visualize the earlier data which you had is like this. From this, it is very difficult to identify where is the river or where is the mountain range or something like that. But once you have hillshade, it's very easy to differentiate. Now what we can do is we can keep this hillshade layer below the reprojected data. And what will we do? We will change the transparency of this above layer. So we can visualize the data like this in 3D basically. So earlier actual data looks like this, but if you have this hillshade and if you will overlay on top of it and just reduce the transparency, you can visualize like this. And if you just want to have colors on top of it, you can go to property, go to symbology and change the color as well. So single band pseudo color, and here I will select the different colors like this. So you can represent your raster data like this. So now you can see the rivers as well, like small rivers, channels as well. Any doubt till this point?
No, sir.
Great. So if you have any question in between, just stop me. And if you are doing along with me, then also if you are like stuck in any step, just let me know. So this is the how this hillshade will look like. Now the next tool is let's say we want to make a contour. Let's say contour at every 100-meter interval, or let's say every 500-meter interval. So I will just write contour. So contour is a line representing the equal elevation. So you will see the tools to generate the contour. I will select the layer, which is my projected layer, and then interval between two contour lines. So I will just write 100-meter interval between two contour, and then attribute name if you want to give anything. So then after you just run the analysis. Like in every case, you can save your data sets. I am just creating a temporary file. So you will get a contour line like this. So it will represent the line with equal elevation. So still you can say it's a very dense contour network. So what we can do is we can generate a contour at let's say every 500-meter interval, so it will not create this much chaos. So this is the contour interval, which is at every 500 meter, and then the below one is at every 100 meter. So what we can do, we can just change the symbology. Like these are the tools which you can use, change it, make the in such a way, adjust in such a way that it will create a like aesthetically appealing maps. So like this you can generate, and then you can add the layers, like what is the elevation at that contour interval, and so forth, like things from the property and going to labels, and you can add the labels at different contour intervals. So if you want to do that, right click, go to the property, symbology, labels, and here single label, and you can select the elevation of the contour, and then just click on OK. It will adjust, like then you can format the contours, like you want to keep it in between or horizontal or vertical rotations, whatever you just, if you want to provide a buffer, you can put the buffer also, and just check it how it will look like. So that things you can do. And then if you want to keep in between two lines, then also you can see callouts, shadow, backgrounds, mask, placement. So placement parallel, curved or horizontal. So curved means like this. So I mean you can use like this and create a maps, beautiful maps out of this. So that's it. Now we'll see some more tools. So which is the next one is the slope. Let's say slope, you have to just give these your reprojected layer and then just run it. So it will give you the slope value, which is like from 0 to 73. So the slope is ranging from 0 to 73. So you know that if slope is 90 degree, it's like steepest line or just vertical line, like steep cliff or something like that feature. 73, it means like around this much you have this kind of elevation. So like you can see at which location slope is high. Also this information will be useful if you want to make a highway in the mountains, or you want to fix a solar solars over somewhere in topography where it is like slopey, or to make out some farms or like tea farms, or like you can adjust like where to do cutting, peeling, and all those kind of information. If you want to do some construction, you have to select a site which has minimum slope or slope less than 5% or 3%, so that you do not have to do so much cutting and peeling during the construction. So this is the slope thing. Then we have aspect. So aspect is like you just use the same DEM. Aspect will give you the direction of your slope. So once you calculate the slope, what is the direction of that slope? Whether that slope is northeast direction, whether that slope is in north direction, or which direction it will give. So now direction is associated over here. So basically direction will be like ranging from 0 to 360 degrees, 0 representing north, and then coming back to the north again with the 360 value. Similarly, 90 you go for west, then 180 for south, like that. So you can have the values ranging of aspect from 0 to 360, and this how your aspect will look like. Then you have some other parameter also, but we'll not go into that. So basically this hypsometric curves are there for like if you are from geology background, and then if you want to create like how much upslope area will be there at given location. So it will be useful for those curves. You can check it out, like so these tools are there, ruggedness index. So this is related to the geology and hydrology related stuff. Relief, it means like in a given a sail, what is the difference between the minimum and maximum elevation, so that will be reflected by the relief at that location. So it's not related to the slope. Slope will represent the change in y with respect to change in x, so delta y by delta x, where relief represents just delta y only, change in y only, not in divided by x. So if you go to some site like on the top of the mountain, you see the nearby pixels, so relief might be very high, but in that case slope might not be that high as well. So that is a basic terrain analysis tools. Any doubt till now?
No, sir.
Okay, so now what we will do is, let's say someone has given us this DM datasets and we want to generate a river map for this DM or watershed area or some other related thing related to the hydrology. So how we can do that thing? So whenever you want to do any kind of watershed delineation or water generation like shapefile and all, the first step will be reprojecting your DM into projected coordinate system, or basically converting your units from degree to meter, which you have already done. So we will not go into that. Can you turn off your mic? I guess. Yeah, thank you. So now to do that, first of all, we will fill our DM. So I will give you the brief introduction about this why, like watershed delineation, and then we will start. So just give me a minute. So now we'll just see, given the DM, because few questions which we saw on the assignment as well, they are related to the hydrology stuff. So we'll just go into a bit detail of it, like how we can derive the different things out of the DEM. So let's say given the DEM, what we want to do is we just want to delineate this watershed network. So which will have these catchments and river network. So like these are the steps. So first of all, we have to download the DEM data, then projecting our data into some coordinate system which is in meter, which is projection coordinate system. And this how the water will flow, we will decide. So water will flow from high elevation to low elevation. So given the value of the pixel, which is let's say 44, we will find out the nearest cell which has the minimum elevation value, or the slope or elevation difference between the given two cell is highest. So here you can see it's like 22. So water will go into that direction, which is in QGIS is reflected by this kind of thing. Let's say 0 will be reflected by north, 1 will be northeast, 2 will be east, like that. So this will be 0, 1, 2, 3, 4, 5, 6, 7. So this is like what, whenever you will get output, it will, this direction will be encoded as a 0 to 7 in QGIS, which reflects this 0 reflects 0 degree, and then the 6 reflects 270 degree, like that. And then we are considering the nearest 8 cell. That's why this method is known as a D8 rule, or the water can flow in the 8 different directions. Now let's say water will flow in this direction, but let's say at some place if your DM has some kind of sinks, so what will happen, that water will try to accumulate over here, and it is not a real situation. So in real situation, what will happen, water will accumulate here, and then once this is full, it will go further. But in the softwares, what will happen, water will go like this, and this is like infinite sink, and then it will go like here only everywhere, it will not able to go further. So what we have to do is we have to pre-process our DM data, and we have to fill this kind of gaps if it has, if sinks. Once we fill the sinks, we have to find out the flow direction. So that we will calculate using this steepest gradient from the given pixel in the 8 different direction. And it will be, we will convert our data like this, in which direction it will go, water. So if you see this this thing like 44, it will go to this 22. So like that, we will just have this kind of arrow. So once we have all this arrow for all the direction, we will connect all those arrow. Let's say if we are interested in this pixel. So this pixel is contributed by how many pixels? So let's say, so we are interested in the center pixel. So here the water is coming from this pixel, as well as it is coming from this pixel. Then you see also see this pixel is going here and then it is going here. So indirectly this pixel is also contributing. This is also contributing because it's going here and then in this pixel. This is also contributing. This is also contributing. So this will go from here and then from there to there. So like this, we will find like how many pixels are contributing at the given location. And then we will find out the accumulation number. So let's say here 10 pixels are contributing. We will write it down as a 10. Then here 9 pixels. So higher the number, we will get larger river. And then we will connect it like this. So which pixel is connected with which part, directly or indirectly. So this kind of topology which will give us the water distribution, which will act as your river network. So like this, you will see that at this location, 11 pixels are contributing. So this is the 1, 2, 3, 4, 5, 6, 7, 8. And then here, like we'll just take a sum of it. Like this, we will create an accumulation map. So here also, this you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then this one is 11. So here you can see this pixel is also contributing, and this is coming from here to there. This one is also. So like this, we will get the number 11 here. That is known as a flow accumulation. That how much flow is accumulating over here. And once we have accumulation, we will find like see all the accumulation value greater than 1000 or greater than 10,000 will represent the major rivers, and we can then digitize those rivers as either 1 or 0, which will give us the water network. So this process we have to follow, this mathematical process basically we have to follow in QGIS now. So according to the process, first step will be the filling our DEM data. So we will use the fill data. So fill sinks. So you have fill sinks, Wang and Liu method is there. You will give your reprojected DEM and you generate the fill layer. You can generate the flow direction also and watershed basin. So watershed basin here will give you the major water basins which are there in your raster data or study area. So those algorithms will take time in running because it requires some processing, as you've seen in slides. So here you can see the fill DEM. We have filled all the, earlier it was like from 2270 to 6886, and now you can see it has changed the values from 2206 to 6997. So values of elevation got changed. And then flow direction, you can see from it's -1 to 7. So -1 means no data, and then 0 to 7 represents the different flow direction, that how the water will flow in each lead direction. So if you locate any pixel and if you go there and just click there and just find out the flow direction, it will tell you that here the direction is 6. It means it will go you like in which direction. So here the direction is also 5. Here if you see that flow direction is 0. So like this you can means north direction. So you can identify the direction. Then the next step will be the accumulation. So for that, the next tool is catchment area. So you give your DEM and flow method. so D8, and there are other flow methods also. And then if you run it, so generally if you take some software such as let's say ArcGIS, in that all the steps are connected with each other. If you are done with the fill direction, then you can use this fill direction to generate the catchment area. But here in QGIS, you can just give the DM value only. Okay, we have to use the fill DM. So if you will not use fill DM, just a minute. So here, if you will not use fill DM, basically what I did is I have used the DM without fill. So what it will give while generating the reverse, it will like terminate at some point, which I showed you in the PPT as well, that it will go into sync and it will create this kind of segments rather than creating the entire river. So that's what error we did. And then what you have to do is whenever you select now elevation, you have to use the fill DM data, which is the pre-processed data. So now you can see that wherever river is there, you can see like main river is there, you can see the higher accumulation value. So now if I right click here and see the catchment area, you can see how many pixels are contributing at this location. 5 into 98 into 10 to the power 8 pixels are contributing at this particular point. Similarly, if I go back and check different other pixels, so you can see here only here I selected in this black area. Still, it is showing me that around 6791 pixels are contributing at that particular location. So it will like either it will give you like number of pixels which are contributing or the area which is contributing. Okay, area of those pixels. So once we get this kind of thing, now we want to create a river lines out of it. So one thing you can do, you can just use the tool like raster calculator and you can calculate the something greater than this threshold will give me the data. So what I will do is I will go to this raster calculator, I will use my catchment area, and then I will say that if it is greater than, we have seen that these pixels are at which, so let's see if it is larger than 10,000. So you can see I have given the 10 to the power 5 threshold. So if the a value is greater than 10 to the power 5, it will give me the river there. So like this, I can generate my river network. Now, wherever the value is greater than 10 to the power 5, it gave me the 1, otherwise 0. Now what I can do is I can digitize those river, like convert this raster data into vector data. So I will go to this raster conversion and conversion from raster to vector data. So I have this river file with me, which I want to convert into vector file. So it will like automatically identify whether it has to create a point, line, or polygon based on the data which is there in your file. And sometimes you can also specify the particular operations as well. So here, so we are converting this river network into line data. So it has done, the process is done. And you can see like how it looks like. So you can just see the attribute table of it. So wherever one is coming, that is your river segments. So it will also select, and then wherever 0 is there, you do not need it. So just remove, you can remove it out. So basically wherever 0 is there, you just don't need them, so you just remove it. So I don't want this data, so I will delete it. So now you can see that I got all the river. So we got till this point, and now what we want to do is we want to delineate a catchment. So this river, so wherever see right now if you zoom it, you can see it has generated the river as a like polygon data, not as a line data. So by doing this transformation, you can specify whether it generated as a line data, point data, or polygon data while doing this uh, particular tool polygonization. And then you can also have some other feature also which will directly convert to raster to vector, where you can specify the type of the vector data which you want to convert. So raster pixel to point or raster pixel to polygon, or what kind of transformations you want to do. So that like here you can see, and if you go to this advanced options, so like which parameters you want to consider. So that these are like some of the options. And then if you don't want to go into that details, so there are some direct tools which are available, such as channel network and drainage area. So this channel network and drainage area you can click, and you just have to give your field DM, and then you just give this. This was already we have generated this like other things. So I just interested in the channels only. So I will just click on channels and I will run it. So this is the another tool like which will also generate the channels. But here like you cannot specify your threshold as an upslope area. You can specify it as a threshold as a river order. So you can see here the thresholds which we generated like this. It has generated that. Now we have done till this point. So what we want to do next is, so yeah. So now let's say if we take any point, let's say this point if we take, and we want to see how much catchment is contributing to this location. Let's say we want to create a, let's say, reservoir there or some kind of breach there. So what we have to do is we have to see like how much water is accumulating at that location, and according to that we will design the dam, like the height of the dam, or if we are constructing bridge, we will design the like lower deck of the bridge accordingly, so that it will withstand the extreme events or the extreme precipitation events and all. So for that, you have to use the tool known as a upslope area. So here, first of all, you have to give the x and y coordinate of the outlet point where you want to generate the catchment. So I will right click. So if this is open, identify, it will not give you ask like you will not able to extract the point. So select this pen button, right click, and just you do proper zooming. Otherwise, it will create a problem. So I will do the proper zooming and I will copy the coordinate in the given coordinate system. So right now all my data is in 3395 only. So I will select my coordinate 3395 only. If it is not in 3395, what you can do is you can go to the set custom CRS and you can select the coordinate system, and you can copy the coordinate in that coordinates, copy the coordinates in given coordinate system, whatever you want. Then after you just copy paste those coordinates. So now after that you have to specify the DM, which is your field DM, method D8, and then just run it. So we just have to give the outlet point and the DM, and the method as a D8, and then you just click on run button and then just wait so that it will generate the upslope area. So you will get upslope area like this, which will show you that how much area is contributing at that particular location. So this much area, and if you see the river network also, you will try to acknowledge this entire thing. Like you can visualize these things, but if you quantify your data, you have to like just do this analysis. So now what we are interested is we want to convert this raster into vector data. So similar thing we will do, we'll go to raster conversion, raster to vector, we'll select the upslope area and then just run it. So you will get something like this from this. If you don't want entire some features, the feature with zeros, it means it is just representing the extra boundary. You can remove, save your file, and then here you go. Now you can see we have the catchment, and then to show it like more beautifully, what we can do is we can remove the inside fill of that particular catchment, and then here you go, you have your catchment, and just increase the catchment boundary and just make it thick like this. So you got the catchment delineated at these locations, and then you can make a map out of it. So this is like how your entire process of watershed delineation will go. And some of the steps you do not require, like here some of the steps we did just for the understanding purpose only. Now if I want to repeat my steps once again, like how you have to proceed, then first of all you have to convert your DM from degree to meter. For that you will use warp tool, warp reprojection, or wrap with reprojection tool. Basically it will convert your data from degree to meter. Once you get that, you will get a reprojected file. Then after you have to fill your DEM with fill sinks. So fill sinks one into you can use, and you can just generate this fill DEM only, no need to generate flow direction or watershed basin. Once it is filled, you can directly go to this channel network and drainage basin part. So the next third one will be this one. You do not need to generate the catchment area as well. You just directly go here, channel network and drainage, give the elevation layer, the threshold, and then you just remove everything and just click on this channel only. It will generate the channel. Once the channels are generated, you can use the upslope area tool, and then you can generate the catchment where you have to give X and Y. So reprojection, the first one, then after fill the sinks. After filling the sinks, you can directly go with this channel network and drainage area. And then the fourth one is the upslope area. And then after, to make it good, like appealing, you can just go to raster to vector conversion. You can make it like remove the symbology. So basically in 4 steps, your entire watershed delineation will be over. Any doubt till this point?
No, sir.
Okay. So this is like how you do anything. I don't know this will be useful to you or not, but for this course, like this, whatever the last lecture we had, this represents the same thing which we discussed till now. So based extraction parameters from DEM, and in the week 12 also you have some of the application related to the site suitability or smart city planning, where you can use this kind of watershed delineation. So if I just go kind of what kind of based extraction, what you can extract from the DEM data. So here like digital elevation model will look like this, and these are the applications of the digitized like DEM map. We can create the slope, aspect, watershed boundary, drainage network, stream channel. So we have done all the hands-on experiment on all those things. Then after we can do the volume of reservoir, how much cutting and filling volume is required. So if I want to do those kind of applications, so how can I do that? So for that you have volume tools in QGIS. So raster surface volume tool is there. You click on that tool. Here you have to select your input layer. So here now, because we do not want to do watershed delineation and all, we will consider our original DEM, which is just reprojected one. And then you have to specify the base level. So this base level will be like if you are doing cutting and filling. So just let me give you some example of it. So let's say you have this surface, and, you have some terrain like this, and you want to make a like flat highway over this terrain, which is like given by this black line. So you can see here this you have to remove, like cut down this area which is above the desired elevation, and then you have to fill down this area using the given soil, or if that soil is not enough you have to procure the soil from somewhere else. So basically this will be like cutting volume and this will be like filling volume, and this will be known as your base level, the level with reference to which you want to calculate the volume. So sometimes this is for cutting and filling volume. If you just want to calculate how much area is there below this line, then also it is work as a baseline. So in that case, it will just find out the area which is below this particular line. So now we will see that like how to do that thing in QGIS. So just give me a minute. So for that, this raster surface volume tool is there. We have to specify our DEM layer. Then after base level. So now we'll see our DEM first. So our DEM is ranging between 2270 to 6886. So let's say we want to find out the area which is less than, like how much area volume is there below the 2500 elevation. Because how much volume is there below this particular elevation. So basically how it will be helpful, like if you decided to make a reservoir over here, then you will just clip this particular area and then you will find the volume here, that how much volume it can store. So it's a similar application. So if you are constructing reservoir of 100-meter tall, so you will take the base which is like it's a 2000, like base is at 2500, and then if you go above it will be like 3500. So if you will write your base as a 3500, and it will find out the volume that it can store. Method, so what you want to do, count above base level, below base level, or subtract the volume below the base level. So it is for cutting and filling, or like this subtract and add. So right now we are just interested in count only below the base level. So whatever is there below this base level, that's only we want to calculate. So it will take as the surface terrain and then terrain of this base level, and it will calculate the volume in between. And then just you can run the analysis. So it will like give you that how much volume is there. So it is below the line, so it will give us in negative. So this will be in meter cube. And you can also see this kind of files it will generate. If you just click on those files, it will give you the entire thing, like how much volume it can, how much pixels are there which are submerged, and how much area is there in terms of meter square, and then how much volume is there in the given unit, which is in meter square. So you can see this around 254 kilometers, sorry, 0.254 kilometer cube volume can be stored. So like this you can do the analysis for volumes, estimating volume. Now we'll see the other analysis which we can perform. So amount of material removed during the miming or digging. So this will be like same will be followed during this cutting and filling volume kind of thing. That hydrological model, so that we also discussed. And then flood hazard monitoring, mapping or flood hazard. So this will be helpful, like once we prepare this kind of river network and catchment and all, we will put this data into some other softwares such as Acros or some other software which will help us to find out the flood hazard, flood vulnerability, like if we can take a buffer around this river also, and we can identify the area which are prone to flood, So this kind of analysis we can do further. So basically you have DEM, you like how will you find the parameter of DEM? So you have DEM reconditioning, so then you have fill the sinks, then do the flow direction, flow accumulation, then stream definition, and then like this is the process which we have to follow, which we already did and we calculated the drainage. Then you create the contour which we also seen. So this is like how it will calculate the slope which we also did. So how DM will look like, slope will look like, slope will like have 0 to 92. In our case, it was from 0 to 75. Aspect will show you the direction of the slope. So which is the direction? So it's like A10 of del Z by del X divided by del Z of del Y. So this will from 0 to 360 degree. So then after flow direction, which we already discussed, the similar example, then flow direction, you will get flow accumulation, then you will get the reverse like this, and then once you have river you can create the catchment and you create this kind of maps, and then we can put the other details and we can generate some maps like this, and then once we get that we can plug that data with Acras or some other flood modeling software and we'll get the output like this. And this is the visibility analysis, which also you can do, like how much area is visible if you are at a given location, so that you will see whether it's there in QGIS or not. Visibility. So there is a option we need this. I think it's not supported. So I think this are not be capable to be doing. You can just see in grass saga. So there are a couple of other tools which are there related to the terrain morphology. Where are different tools are there: hypsometry, ENG maps, basic terrain analysis. If you see this slope, aspect, plane curvature, profile curvature, convergence index, flow, so all you those parameters you can find out like LS channel network all together only. Like you just do this thing and you'll just find out everything together. Channel network distance, valley depth, and all those things you can do directly. Then you have some tools related to hypsometry, mass balance, morphometric features. So in morphometric features, you have slope, curvatures, thresholds. So you get this features as well. Then surface area, slope aspect, and curvature value. So these are the different tools. Like you can just go through it: upslope, downslope, curvature, wind effect. So these things we can do. Cross-sectional profile now. If you take any river, how will it look like if you go from top of the river to the base, you know that it will have give you, just select this, edit, and we will plot the long profile of the river. So let's say if we take this river and let's say we will take the boundary of it, or we can directly extract the pixels at this locations, and then after we can just convert that into a this kind of river longitudinal profile plot. So you can see like from high elevation to low elevation, what is the slope of the river, and based on this we can find out the stream power of that river, so that how much power it has to deposit the sediments from one location to another location. So we can integrate this with the value of slope, how it is changing in how much area. Then if we have the data about the nearby geology of rocks, whether igneous or sedimentary, we can find it out like how much capable that river is for the erosion. So you can just plot out this stream power value at different stretch, and you can see which zones are susceptible for the erosion of the river. So those analysis you can do further. Uh, any like question?
Yes, sir. I have a question in your previous year lecture. We can see um,
Yes.
NDWI. What is your NDWI formula?
Yes, so I have correct, like it's wrong there.
Yes,
You
yes.
have to use near infrared. So like it's actually that video
Green
is,
minus near infrared divided by green plus
yeah,
DN.
yes.
Okay, sir.
So
Okay, sir.
yeah, I have to, like, it's in that video my voice is not audible.
Yes,
So
sir.
I think I have to re-record that video. I have already recorded that and just I will upload it.
Okay,
So
okay,
I
okay.
have
Sir,
corrected that thing accordingly. Whatever you told in comments, I
okay,
have
okay.
corrected there.
Okay, sir.
So there are like there is one more index which is like modified MNDWI. So it's like water index only, but it's like modified newer version of it. If you take this modified NDVI index, in that let's say in that we are using the green and SWI, so I got confused between those and other thing, like it's green and near infrared only, like whatever. Oh, okay, so just go through the formula once. It's like based on this formula only.
Okay, sir.
It was wrong. I have corrected it. I will upload one more time it.
Okay, 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 sir.
Now we are just left with one particular lecture. So what we are going to do is we will try to cover some MCQ questions during that class regarding the GIS part. So like whatever the gate questions are there and some of the few questions. And apart from that, what else we can do? Should we cover any case studies or any question answer like from entire syllabus together?
Okay, sir.
So what do you want to do? Like, do you want to do some case study or like hands-on applications? Or are you interested in just solving the question answers like as your exams are also approaching? So what might be a good idea? So just question answer or do you need hands-on sessions?
Question answer session is most
So what
helpful.
I am thinking, like if we are taking question answer, we can take the question answer of all the 12 lectures together. So that might be helpful for upcoming exam if you have enrolled like for exams.
Yes, yes.
So we will try to do that so that it will be helpful to you. Anything else specific that you want to ask?
Sir, DIP related,
Yes.
DIP mathematics related, जो pixel, any questions तो हमें.
Okay, so I will like any particular thing like we solved a huge number of questions on that part, but should we take more
Some
of those
questions are
questions?
filtering or thresholding, any
Uh,
types of questions.
so should I cover like which kind of topic should I cover more in that? In
Or
DIP, like there are a
DIP,
couple of portion are there. Like first is related to the band statistics, where this correlation part and all were there. Second one is in the contrast enhancement part was there.
yes.
Then in one extra lecture, I like in the last Saturday, I discussed about filters as well. So I mean, which part you are more interested? So we will take the questions on that, or specifically, or entire topic you want some kind of revision or something like that.
Question like more.
So I will try to put some questions from that, but if you still like not in like not good with any particular topic in that DIP also,
Okay, sir. Okay, sir.
Joe,
Okay.
let me know. So I will try to incorporate that because like after that lecture we'll not meet probably.
Okay.
So you just mention me on the comment section, or if you recall right now, just tell me. Uh, I will take one questions from each topics if, and then if you're interested in some topics, we will try to cover some questions on that in detail.
Okay, sir. Okay, sir.
Okay.
Okay.
So I think with that, if questions are not there and our content is also over, so we can close this session.
Okay, sir.
Okay.
Okay, sir. Good night, sir.
Right. Bye.